Okay, in this video what we're going to do is we're going to explore how to use a map to determine the actual distance between two places. So in this particular case we can see that we're trying to find how far is it from Port of Spain to Rio Claro. And on the map here we'll just kind of indicate where those are. Here's Port of Spain over here, and here's Rio Claro over there. And so to do this, what we need to do is we need to look for a way to connect the image of Trinidad, which is the country we're looking at here, to the actual distances of Trinidad. And so to do this, we're going to set up a proportion. Now, like every other proportion we've used so far in this unit, what we're going to do is we're going to start with our same sort of three parts. We're going to have our words, and then we're going to have a known ratio and an unknown ratio. And we're going to get a little more specific for some of these. Now, words, first of all, whenever we're using a map, what we're actually trying to look for is a connection between what's called the image, in this case the image is a map, and real life, or the actual distance. So we're looking for the distance in the image compared to the actual distance. And what we need to be looking for in the case of a map is we're looking for the scale of the map. And the scale is actually what is the known ratio. Remember, known means we know both parts of it. The scale is the piece of information that connects the size in the image to the actual size. And so if we look in our map, we can actually see that here is the scale up here. Right? This tells us that this distance, whatever this distance happens to be, this distance right here is 30 kilometers in real life. So in order to do this, we need to find out, well, how long is that line? So the best way to do that is to use a ruler. And I have a ruler. So if I line this up, we can see that from 0 to 30 kilometers is exactly 2 centimeters. So I'm going to write that in as my known ratio. So 2 centimeters in the image, as measured by my ruler, is the same as 30 kilometers in real life. So we now have a ratio that connects the size in the image to the actual size. So now what we're going to do is we're going to try to connect we're going to answer our unknown here, which is the distance from Port of Spain to Rio Claro. So the actual distance, I don't know what that is. That's what I'm trying to find. So that will be my variable. Now the distance in the image is from here to here. I don't know what that is until I measure it with my ruler. So let's do that. So if I look at my ruler now, the distance from Port of Spain all the way down to Rio Claro looks like it's about 35 millimeters, or 3.5 centimeters. So I know it's going to be a little more than 30 kilometers because 3.5 is bigger than 2, but to find that out, we're actually now going to use one of our proportion solving techniques. And in this case, I actually see a pretty good connection here, right? 2 times 15 is 30, so I'll just do the same thing over here. 3.5 times 15 is going to give me some value. And to find out what that is, I'm actually going to use my calculator. So on my calculator, I'm just going to actually type in 3.5 times 15 equals, and I got an answer of 52.5. So that tells me that n is equal to 52.5 kilometers. Remember, kilometers, the actuals are in kilometers and the images are in centimeters. So the distance from Port of Spain all the way down to Rio Claro is 52.5 kilometers. Now this question gets us to do something a little bit differently. This is actually something that's commonly referred to as shadow reckoning. And what shadow reckoning is it's a technique that was developed way back when by one of the ancient Greeks as a technique to measure the height of one of the ancient pyramids without actually measuring it. He used the relationship between his height and his shadow length, and then measured the length of the shadow of the pyramid in order to determine its height. So this is what's called shadow reckoning, and it is a form of indirect measurement. So in this case here, we have a dog that's 45 centimeters tall casting a shadow that's 30 centimeters long, and a nearby tree casts a shadow that is 220 centimeters long. So the question is, how tall is the tree? And so usually in shadow reckoning questions, the best thing to do is to draw a picture. So I'm going to draw a picture right now. And voila, there is my beautiful hand-drawn picture. Now, we can still use the same setup as we use every other time, right? We're going to start with finding out what are we comparing in words, and then looking for a known ratio and an unknown ratio. Now, in this case, the words are, what are the two things that are being compared? And in shadow reckoning, it's always the same two things. We're comparing the height of something to its shadow. So I'm just going to put height to shadow. And just like every other thing, it doesn't matter which order we write these in, just as long as everything else matches up. So height to shadow. And in this case here, my known and unknown, I can actually be more specific. Remember, the known ratio is what do we know that connects both the height and the shadow? Or in this case, which object do we know both the height of it and its shadow length? And here you can see it's the dog, right? We know both the height of the dog and the length of its shadow. So really our known ratio is the information about the dog, and the unknown ratio is the information about the tree, because we only know its shadow and not its height. So let's just fill in the information that we know. These are both going to be ratios. The height of the dog, this is kind of like a table, is 45 centimeters. Notice that I put it in meters in the picture, but I'm just converting to centimeters. And the dog's shadow is 30 centimeters. The height of the tree is what I don't know. That was labeled as H. And the tree's shadow is 220 centimeters, or 2.2 meters. And so now, once again, I have a proportion. And I'm going to look for my different connections here. If I look for the pattern within a ratio, I don't really see that right away. Some of you might, but I don't see it, so I'm just going to ignore that one. And likewise, if I look between, I don't know how to connect 30 and 220 using multiplication or division, so I'll skip that. And I will go directly to cross products. So here are my cross products. And so let's just write that out. 30 times H is 30H, and 45 times 220, I do not know what that is, so let me bring in my calculator. So my calculator, I'm just going to go 45 times 220, and that equals 9,900. So 9,900, and divide both sides by 30. H equals 9,990 divided by 30 equals 330 centimeters, or 3.3 meters. So I can now look at this and say, yeah, the height of the tree is 330 centimeters, or 3.3 meters. And that's how we can use the relationship between the height of an object and the length of its shadow in order to determine the height of something else.